Hello again. Once more, we are going to do the endocrine system today, specifically just this board right here. So on this board, we're going to have a few different organs. We're going to start in this top left corner. So here we have a cross section of the hypothalamus and the pituitary gland. The pituitary gland is anchored to the hypothalamus through this structure, which is called the infundibulum. Now remember, for the pituitary gland, we have both an anterior and posterior component. Anterior is going to be glandular tissue, posterior is going to be neural tissue. On this model, I can tell this is posterior because these neurons are coming down. And so this is going to be the neural component. So remember that the hypothalamus produces oxytocin and ADH, and then from those neurons, we're going to store oxytocin and ADH inside of the posterior pituitary. The anterior pituitary is going to produce ACTH, adrenocorticotropic hormone. It's going to produce TSH, thyroid stimulating hormone, our two gonadotropins, FSH and LH, follicular stimulating hormone and luteinizing hormone, prolactin, PRL, and then also human growth hormone, or just growth hormone. Next up is this organ here. This is the thyroid gland. We can tell we're looking at the larynx model here. So the thyroid is targeted by TSH, which was produced in that anterior pituitary. The thyroid stimulating hormone targets specifically follicular cells of the thyroid to produce T3 and T4, which are also known as the thyroid hormones. Thyroid hormones target all of our general body cells and stimulate the metabolic rate. So their overall effect is increase basal metabolic rate. On the posterior aspect of the thyroid, we can see our parathyroid glands. The parathyroid glands are going to produce parathyroid hormone, and that is going to be an antagonist to calcitonin, which is actually produced by the parafollicular cells of the thyroid. So the parathyroid glands, parathormone or parathyroid hormone, is going to increase our blood calcium. It does so by stimulating osteoclast activity. When we stimulate osteoclast activity, we're going to dissolve more bone and release that calcium into the bloodstream. Calcitonin, which is produced by the parafollicular cells of the thyroid, is going to decrease osteoclast activity, which allows our osteoblasts to utilize that excess calcium and build up bone, and that helps decrease our blood calcium levels. On the right-hand side here, we're going to have our adrenal gland, always associated with our kidneys. Our adrenal gland has a cortex and a medulla. The cortex is going to produce all of our steroid hormones, and the medulla is going to produce our epinephrine and norepinephrine, which are both hormones and neurotransmitters. For the cortex, there are three layers: zona glomerulosa, zona fasciculata, and zona reticularis. Zona glomerulosa, we have aldosterone production. Aldosterone is going to target our kidney tubules and increase the resorption of calcium and sodium, and then that is going to cause water to be reabsorbed into our bloodstream, which helps increase our overall blood pressure. Then the zona fasciculata and the zona reticularis are producing cortisol. Cortisol is our short-term stress hormone, and that is going to increase sugar in our blood by causing cells not to utilize sugar. And then it's also going to increase inflammatory actions, and it's going to stimulate our white blood cells to migrate to our lymphoid tissue. So our short term, a little bit of stress gives our brain some sugar, and then long term, this causes some damages to our tissue through excess inflammation and excess migration of our lymphocytes, which causes our immune system to kind of be dampened. This cortex is stimulated by adrenocorticotropic hormone from our anterior pituitary. And ACTH actually targets it to release cortisol. So ACTH is long-term stress. We produce a lot of cortisol. Cortisol itself is short-term stress. We produce a little bit on its own. Then next to that, we're going to have a testy, and below that we have an ovary. So these are both our gonads. These are going to be targeted by our gonadotropins. The follicular stimulating hormone is going to stimulate the maturation and production of sperm cells and egg cells. And then our luteinizing hormone is going to stimulate the production of testosterone in the testes, and then estrogen inside of the ovaries, as well as progesterone. Then on the bottom left here, we have a pancreas. In the endocrine system, the pancreas has endocrine cells in a little island called a pancreatic islet, and those are going to produce insulin, glucagon, and somatostatin. Alpha cells produce glucagon. Glucagon is going to help raise our blood sugar by breaking down glycogen. And then insulin is produced by beta cells. It is going to stimulate our general body cells to utilize sugar, and that helps reduce our blood sugar levels. And then the delta cells produce somatostatin, which helps regulate or inhibit the action of the alpha and beta cells, so we don't overproduce too many of those hormones and potentially either increase our sugar too much or decrease our sugar too much. And that is the endocrine model here. Hope that helps.